Hi class, this is Neil, and this is lesson 7, a continuation of reciprocal trig functions. In this lesson, what we're going to look at is how we can apply our knowledge of reference angles to extend the use of reciprocal trig functions for all values of theta. So we want to extend what we've been doing with reciprocal trig functions, which was before just in right triangles, to everything in the circles we've been working with. Okay, so what we're going to do now is just review a few of the definitions of tangent and also some definitions of reciprocal trig functions. So first of all, tangent of theta. Well, one way we can think of tangent of theta, the way that you've thought about it most in your sort of math career, is that tangent of theta is equal to opposite over adjacent. So the opposite side of an angle over the adjacent side. We've seen, though, that another way we can think about tangent of theta is the sine value over the cosine value. And recall we did a proof about this a few lessons ago. All right, so let's take a look at definitions of the three reciprocal trig functions that we've looked at so far. So the first is secant. Secant is abbreviated SEC. And secant of theta is the reciprocal of cosine. And so the way we show that it's the reciprocal is writing 1 over cosine. Now, I think a more useful way to think of it is that it's the same thing as the hypotenuse over the adjacent side of a right triangle. I think this kind of grounds it a little bit more in the reality of triangles that we've been working with so far. All right, the second reciprocal function we'll talk about is cosecant. Cosecant is abbreviated CSC of theta, and that's really equal to 1 over sine of theta. So it's the reciprocal of sine. Now, another way we can think about cosecant is that really it's just the reciprocal of sine, so it's sine flipped upside down, so it's hypotenuse over opposite. All right, and the third reciprocal trig function that we've looked at is called cotangent. So cotangent, as you recall, is really the reciprocal of tangent. So we write 1 over tangent of theta to show it's the reciprocal. And another way to think about that is it's really the adjacent side over the opposite. So it's the reverse of how we've been talking about tangent. Okay, so let's take a look at how we would use these ratios to help us solve problems in circles on the coordinate plane. All right, so in this example, we're told the terminal side of angle theta, drawn in standard position, intersects a circle in quadrant 3. So that's an important piece of information. Determine the value of cotangent of theta. Determine the value of theta if cotangent of theta equals the square root of 3. If needed, round to the nearest hundredth. So let's just look at part A first. So let's kind of draw our circle centered at the origin. So there's our circle. All right, we know that angle theta in standard position intersects our circle in quadrant 3. So the terminal side intersects in quadrant 3. So I'm going to just show that here. Right, there's my point of intersection. Now, we're told, we'll just show theta here. And let's go ahead and draw in our reference triangle. So here's my reference triangle here. There's my reference angle. All right, so what we're told in this problem is that cotangent of theta equals the square root of 3. And we want to know what is the value of theta. Well, an easy way to find this is just to use our inverse cotangent. So all we're asked to do here really is find our angle. So let's see what happens when we do that. So I'm going to write cotangent of -1 of both sides. All right, so that's going to cancel out cotangent there. And I'll get theta equals cotangent -1 of square root of 3. That tells me theta equals, but to find theta, I'm actually going to have to turn to my calculator. So we want to make sure we're set in degrees. We are. We look in the functions menu to find cotangent. Now I'm just going to put in square root of 3. And we see that that's a 30-degree angle. All right, let's come back and look at our circle and see where that angle is located at. So we're told theta is 30 degrees. Now, we got to look at our circle here. When I look at my circle, I see that our angle theta is really in quadrant 3, so it has to be between 180 and 270 degrees. So this here, that 30 degrees, really tells us what my reference angle is. So to find the value of theta, I really need to take that 30 degrees and add it to 180. And now I see theta is equal to 210. And that's my final answer for part A. All right, let's look at part B. Determine the value of secant of theta. Okay, so first of all, I'm given a value for cotangent of theta. And cotangent, I'm told, is the square root of 3. Now recall from earlier that we said that cotangent of any angle is equal to the adjacent side over the opposite side. All right, so you might be asking, well, I don't see a fraction here. All I see is the square root of 3. But we can fix that by just putting the square root of 3 over 1. So now this tells me that the adjacent side is square root of 3. The opposite side is 1. I'm going to write that into my triangle. So here's my angle. This side is really square root of 3. This side is 1. Now, thinking about in which quadrant we're in, what does that tell me about those values? Well, it tells me they're negative because my x value, or my adjacent side, is in the negative side of the x values, and my y value is also negative. So this point here is really negative square root of 3, negative 1. Okay, we're almost there. So secant of theta. Well, secant equals the hypotenuse over the adjacent side. All right, well, we know the adjacent side has a length of this negative square root of 3. We need to really find what is our hypotenuse here, or what is the radius. And to do that, I can just use the Pythagorean theorem. So it'd be negative 1 squared plus square root of 3 squared equals r squared. All right, so simplifying, I get 1 plus 3 equals r squared. 4 is equal to r squared. Let me move my screen up. 4 is equal to r squared, and therefore r equals 2. Okay, so my hypotenuse here is 2. secant being hypotenuse over adjacent, I've got my values now. So it's negative square root of 3 over 2. So really the important thing here is you've got to think, what quadrant are you in? Because the quadrant you're in is going to determine whether those values are negative or positive. I think it's always important too to draw your triangle for yourself. All right, that's the only example for this lesson. And I believe there's 5 practice problems for you to go through. All right, I'll see you in tutoring hopefully, or in class.